Okay, so last week we spent the entire week graphing sine and cosine, and I hope that we kind of maybe feel somewhat okay about graphing sine and cosine now, what they look like, how to find the period, how to find the amplitude. And so now this week we're going to graph the other four trig functions. Today we're going to graph tangent and cotangent. Tomorrow we're going to graph secant and cosecant. And that would be the 6 trig graphs that you need to know how to do. And then by the end of the week we'll move on to like inverse trig stuff. And I think, I don't know, maybe into next week we might be looking towards another test. I don't know, definitely maybe the beginning of the next week. We'll have the rest of our chapter 4 tests. But here's the big difference between sine and cosine and the other 4 graphs. Tangent, what is the ratio for tangent? Y over x, which means a couple things. One, can tangent be undefined? Yes, which means what do undefined places look like on my graph? One over x. When I graph that, there's definitely a place that's undefined, right? So what does that look like when I have an undefined place on my graph?
Space.
Could be a hole, or what else could it be?
Blank.
What does this graph look like?
That's that function one?
No.
I can't remember. Probably should just tell us.
Rational function.
Anticipation.
What's it look like? Come on.
Remember. Hero drew it like 5 minutes.
Does it like a stick off and then another plate stick off?
Like this?
Like this, like this.
Nope, that's not what they do.
That's what it looks like. Is that what you drew, Oliviero?
No.
No.
It was like, wait.
That's what it looks like.
That's what tangent function looks like?
No, that's what this looks like. He's drawing tangent. I'm not to tangent yet. I'm trying to get you there.
Oh.
I'm trying to do this right now. This is undefined at x equals 0, yes? What does that look like on my graph when it's undefined at 0?
That never goes to true.
What's that called? An asymptote, right? An asymptote.
We should have said what is it called when it gets close or something never touched it. That would have been so
Undefined. An asymptote. A line that your graph can't get to because it's undefined there. So when we graph tangent and cotangent and secant and cosecant, they're not going to be as pretty as sine and cosine because they're going to have asymptotes. So let's think about that first. Asymptotes are going to be where tangent of x is undefined. Yes, dear. Tangent is what ratio again? Y over x, which means it's going to be undefined when x is 0, yes? Where does x equal 0? So it's going to be undefined when it's like something over 0. So it's going to be undefined at theta, we'll say theta, x equals pi halves, 3 pi halves. Is that the only places it's going to be undefined? These keep going forever, right? So technically, would it be undefined at every interval of pi halves, 3 pi halves, keep going, 5 pi halves, 7 pi halves, 9 pi halves, 11 pi halves, negative pi halves? No, we can't just say those two. Asymptotes are going to be at pi halves plus any 2 pi in. If I just keep adding 2 pi to that, or at 3 pi halves plus 2 pi in, because they're just going to be infinitely repeating. These are periodic functions. Technically speaking, we could just say pi halves plus pi in, because if we add pi to pi halves, we get 3 pi halves, right? Like we could condense that, but that's okay. So let's draw some asymptotes in here, and then we'll make an XY chart. So let's draw our favorite. What's our favorite? 2 pi, right?
Now it's just all over.
Can I tell you a funny story? Last hour, someone, I won't say who, a fly flew in their ear, and I don't even really know what happened because I didn't see it, but glasses flew off their face, and they hit themselves in the head with a pencil trying to kill a fly. So it wasn't Colton.
Colin, who was it? Who's
And then I think they felt very bad because I almost yelled at Cora because I thought Cora was talking again.
So it wasn't Cora and it wasn't Colin. And it wasn't Colton. They had glasses on. Did he hit somebody else's glasses off? Or he?
Those are their own glasses.
Man or woman?
I'm not saying. Okay, I've said too much.
Right light.
People get scared by asymptotes, but the great thing about asymptotes is they kind of bound your graph. So I know there's going to be an asymptote where? What is going on? Where are there going to be asymptotes on this graph? Olivia, get it together. At pi halves, there's going to be an asymptote. So I'm going to draw an asymptote as a dotted line that my graph is never going to touch. Also at 3 pi halves, there's going to be an asymptote. Because that's where tangent is undefined. If you try to take tangent of pi halves, it's undefined. Try to take tangent of 3 pi halves, you get 0 on the bottom. It's undefined. Where else on my graph that I've labeled will it be undefined? Yeah, and here's what's great. They're equally spaced, but definitely at negative pi halves and negative 3 pi halves. So what we need to do is pick some points in between the asymptotes and see what's happening. So I know you don't have this lovely ability to erase on your paper, but I do, so I'm going to erase this. And this is why you should write your own notes, but you complain so much, so and you have plenty of paper. You can just write it underneath there. Don't check room down there. I'm not going to pick asymptotes on my graph, because on my XY chart. I already know it's 0. So let's look at this in between these two asymptotes. What's halfway in between these two asymptotes? 0, and then pi fourths are going to be the next one. Halfway in between here and here is going to be pi fourths. I'm with you. That's my other one. You have the hard answer already. So let's just go ahead and pick those 3 points. Pick the one in between, which is 0. Halfway between 0 and pi halves is pi fourths. And what would be halfway between 0 and negative pi halves?
You're going to have to pick a lot of points.
Settle down. You're going to be okay. Remember the first time we graphed sine and we picked like 8,000 points and then we learned the pattern and we didn't have to pick 8,000 points? That's the idea. This is the first one. Settle. What's the tangent of 0? 0, great job. Tangent of pi fourths is my favorite tangent. 1, because it's square root 2 over 2 over square root 2 over 2. What's the tangent of negative pi fourths? It's in quadrant 4. Negative pi fourths is in quadrant 4, so it's negative. Oh, look how nice this is. Let's see. At 0, 0. And then halfway in between is going to go up to 1. And halfway back here is going to go to negative 1. And we could pick a lot more points here if you wanted to kind of see what's happening. But here's the things I want you to keep in mind. 1, these are smooth curves, not jagged edges, not straight lines. And 2, the asymptotes, they get closer and closer to the asymptotes. So this side is going to go up. It's going to go through 1, it's just going to keep going up like this, kind of like this. And this side's going to turn and go like this, and it's going to keep going down towards that asymptote. And look what happens if we pick the halfway between point in every asymptote. I cannot talk. The halfway point in between each asymptote. What's the halfway between this asymptote and this asymptote? Pi. And what's the tangent of pi? 0. And what do you think is going to happen when I pick the point halfway in between each one of these? It's going to always be the fourths, right? The pi fourths are my favorite tangent. So if you don't know halfway in between, what was this? Pi halves and pi would be 3 pi fourths. That would be this way. And then pi and 3 pi halves would be 5 pi fourths. Is that true? See how you kind of need to know all these unit circle stuff? 3/4 is over here. Is tangent negative or positive in that one? Negative, great job. And then down here in quadrant 3, it's positive because it's negative, negative, which means this side goes down to -1, this side goes up to +1. So look what happens. Does it look exactly the same? Mine doesn't look exactly the same, but it's supposed to. Mine definitely doesn't look the same. A little curvier on that first one. So here's what's great about tangent. If you can find your asymptotes and graph one, it just repeats itself over and over again. So what's going to happen back here? Do I need to plot these points on my XY chart? No, because halfway in between is going to be 0, and then it's going to go to 1 and to -1. This one I don't have the whole thing, it's just half of it. So it's just going to be the 0, and this side would go down. That side would go up. That would be filling up my entire graph there. If that was your graph, yes. You can't leave your graph blank because that's implying that it didn't continue, right? That's why when we make our own graphs, we tend to set the chart so that it only makes 2 periods. We're going to talk about the period of this in a minute. The period is how long it takes to repeat itself. How long does it take tangent to repeat itself?
1 pi.
Ah, you're right.
Really?
Yeah. Because from here to here is 1 pi, and then it repeats itself. One set of asymptotes is a period, and then it repeats itself. So how many complete periods did I graph up here? Yeah, because I have 3 nice ones and then a half and a half joined together, right? Oh, how exciting. So again, your whole homework can't just be graphing tangent, so they're going to do these transformations. And I just wrote this the same way that we wrote sine and cosine to talk about what these do to our graph. Basically, what you want to do is find your asymptotes, find the point in between, halfway in between. Those are going to be like our go-to key points. But some formulas here. The period still changes with whatever b is, but now the formula for tangent is pi over b, not 2 pi over b. So you got to make sure you keep that straight, because tangent only takes 1 pi to complete the cycle before it repeats itself. Amplitude was defined as like the distance between the max and the midpoint. So for tangent, was there a max and midpoint for tangent? Yeah, it keeps going forever. So there is no amplitude, right? They say the amplitude is undefined. But think about, what is an A value still going to do to your graph? It's still going to stretch it, which means it might not be at 1 and -1, right? Like if there was a 2 in front of it, which we'll do in a minute, that means it's going to be stretched up to 2. So it could like look a lot thinner, stretching that kind of S shape out, or squishing it down. So we don't say there's an amplitude, but there could still be a stretch. All these other things still do the same thing. D still makes a vertical shift, which means they can shift your graph up and down. C is still a phase shift, which means it can make your graph move left to right. We will graph some phase shifts again with the graphing calculator later this week. By hand, I will not make you graph phase shifts because I'm the nicest teacher in the world, basically. Here's the hard part, though. The asymptotes can change, all right? And so because the asymptotes normally, look, they didn't leave me much space here. I spaced this out, but it didn't, it changes itself. Normally the asymptotes would be consecutively at -pi halves and pi halves. What I am going to make you do on a test is find 2 consecutive asymptotes for me. And even with the period change, the asymptotes could change. So what you need to know is this right here. Like, this is kind of a big deal. To find 2 consecutive asymptotes, you're going to have to set whatever's with that tangent, which I call bx minus c, set it equal to 2 consecutive asymptotes. So I always do -pi halves at pi halves, and that gives me my first set of asymptotes, and then I just make them equally spaced from there. Okay, so we're going to practice this a little bit, and then after we do secant and cosecant, we'll kind of summarize that again. So you can see as you open up your notes, it's just a whole bunch of graphs. How exciting. We love graphing. Colin, do you have nothing to do?
I just finished my.
Oh my gosh, look, I have stuff for you.
He's saying he doesn't do his
I
school.
want me to work on my calculus.
You're coloring, so you can break.
I'm just adding details.
Here you go.
Ron, are you gonna be a professional artist?
Here, come.
Yes.
This is the answer key. 2 points each, okay? So, like, if they shade wrong, or they don't do a dotted line, right, you can take off, like, half a point. If their line is wrong, then you take off at least a point. Alright, they're looking for slope, line, intercept, and then shade.
Call
There's
me
12 of them, which is 12 times 2 is 24 points.
What's your middle name?
Okay, go.
Colin.
So, with sine and cosine, I always said find your period, break it in half again. For tangent, you gotta find those asymptotes first. Good question. Okay, sorry. So you have to know the rules for finding asymptotes. Normally, they're at negative pi halves and pi halves. Sometimes you can just figure it out. But the way that I said to do it, take whatever's here, which is x over 2, and set it equal to those normal two asymptotes, which is negative pi halves and pi halves. And when you solve those equations, you are going to get your first two consecutive asymptotes, and then they're all going to be equally spaced from there. Because basically, this is changing the period, which is changing your asymptotes. What would I do to solve that? Solve for x, I would just multiply by 2, yes? And I would get x equals negative pi. Or make a proportion, that would work too. And over here, I would get x equals pi. Yes? So what does that mean? That means that my two asymptotes are now going to be from negative pi to pi, which means how far apart is that? Yeah, that's 2 pi. Do you agree with that? From negative pi to pi? That's because the period changed. If you do the formula for period, which you don't really have to do, but I told you the period is pi over b. If I did pi over 1/2, do you agree that our period has changed to 2 pi? That's where our asymptotes change. So if your asymptotes change, your period changes. It's still going to be the same shape. It's just now spread out. If I want you to graph a minimum of 2 periods, you have to know how to put these asymptotes on here. So I'm going to say negative pi to pi. Where would my next asymptote have to be? If I was going positive, if they're equidistant apart. Which one? Do you agree that 3 pi is the next asymptote? They have to be the same distance. So this is 2 pi. So the next one evenly spaced is not going to be the asymptote. It would be 3 pi. You see what I'm saying? So I'm going to draw that in. If this is all I graph, would this give me 2 full periods? Yeah. If you want to go to negative 3 pi over here, could we do another one? We could. But whatever you label, you got to fill it. They're not very evenly spaced. So. With tangent and cotangent, you got to find the asymptotes. If you don't find the asymptotes, you're probably going to miss the problem. And we can make a chart here, but I'm hoping you're going to see what happens here. Here's what's amazing about tangent if you can find the asymptotes. Halfway in between your asymptotes is always going to be what? 0, always. So if you aren't sure, you can check. You can plug 0 in there, tangent of 0, still 0. And halfway in between the asymptote and your 0, which in this case would be pi halves or negative pi halves, right? You don't really have to label it since you label pi, but 2 pi. Halfway in between that should always give you the force, which gives you a tangent value of 1 or negative 1. And again, we can check. I always check the first one to make sure it's right. If I'm not sure, this would be pi halves, yes?
Yes.
If I plug pi halves in there, is pi halves over 2 the same as pi force? Yes. And what is the tangent of pi force? 1. But I'm actually picking pi halves here. Oh, I guess I would help if I labeled my y-axis. Which means, does this look pretty much the same as what we just graphed on the previous page? Except what changed? The x-axis changed, which is why the same rules apply. If you don't label your x-axis, then we have issues when I'm grading it, because I need to know that you know what to label the x-axis by. And then what's going to happen halfway between pi and 3 pi? It's going to go to 0. And then what's going to happen halfway in between those? It's going to go up and down to make that same shape, yes? So this side's going to go down to 1. This side's going to go up to 1. I wish mine looked the same every time I did it, but they never do. That is 2 full periods, so I don't have to graph any more than that. Questions? Let's graph cotangent. Cotangent, is it going to have asymptotes? Is it going to have asymptotes in the same place that tangent has asymptotes? No, because cotangent is switched. Cotangent is y over, nope. Cotangent is x over y, so it's going to have asymptotes everywhere that y equals 0. And where does y equal 0? On the x-axis, right? Like 0, pi, 2 pi, 3 pi. So it's going to have asymptotes where y equals 0, which means at values like 0, pi, 2 pi, 3 pi. Or could I just say asymptotes at pi n? Would that work? Any multiple pi where n is an integer? What? That would still work, right? But this would, but if I just say n is an, if I just say n is an integer, integers can be odd too, right? Like I think this works. I'm going pi n. So that means if we go like we did before, our first one from 2 pi to negative 2 pi. Right? There are going to be asymptotes on cotangent at every multiple of 0 pi and going from there, which means the y-axis is an asymptote. Do you agree with me on that? Because at 0, if you try to do cotangent of 0, you get 1 over 0, which is undefined, which means there's going to be an asymptote here. Or else is there going to be an asymptote? At pi? At 2 pi? And again, look how they're evenly spaced, right? They're pi apart because the period of cotangent is the same as the period of tangent, which is pi. Where else is there an asymptote?
Negative pi.
And negative 2 pi. So good and bad things. Good thing is they're very similar, tangent and cotangent. Bad things are very similar, so it's easy to confuse them and graph the wrong way, which is why if you're not sure, pick a couple points. But it's still the same idea. Pick the halfway in between and halfway in between. I told you you don't have to graph faces. Didn't I tell you that?
Yeah, but what happens if you have to identify a graph?
Tricky. Especially if there's a negative. I'm going to talk in a minute. But let's talk about the similarities here. If we pick halfway in between the first two asymptotes, halfway in between 0 and pi gives me what?
Pi.
Halves. Pi halves. And if I do cotangent of pi halves, that's going to be 0 over 1, which means halfway in between your asymptotes is still a 0, which is awesome. Halfway in between is a 0. I'm going to go halfway in between all of these. I'm so excited. These are all zeros. And then what if I pick halfway in between my 0 and my asymptote? Halfway in between 0 and pi halves is My favorite, pi fourths. And what is, if the tangent of pi fourths is 1, what is the cotangent of pi fourths? Still 1, just the reciprocal.
Yeah, why you gotta do that?
And if I pick 3 pi fourths, which is the other side over here, that's quadrant 2, which is -1, which means it still kind of looks like that shape, only what happened?
I don't know, someone messed it up.
How does it look different than tangent?
Then got flipped over.
It's flipped, right? So 2 big things to look for when you're graphing tangent and cotangent. 1, the asymptotes. The asymptotes are in different spots. That's how I identify them. 2, tangent and cotangent, like they're flipped from each other. Tangent goes this way, cotangent goes this way. But the way you graph them is the same. You find your asymptotes halfway in between, halfway in between. But if you don't know which way it goes, pick one of those points and just make sure, and then you can just repeat the pattern, right? So you don't actually have to pick all those points. What I do want you to get in the habit of doing is graphing those 3 points. What I don't want to see you doing is just graphing that and then winging it, because it's inaccurate. Yes, dear. Your sweatshirt? No. You'll be okay.
You said no or you said go?
I said no. I said sit down. That's good. Stop right here. For leaving my class.
I heard go, but you said no. I was like, where are you going?
Again, notice the period on this is the same as tangent, which is pi over b. There is no amplitude. The domain is all real numbers. Nope, the domain is not all real numbers. The domain is not the asymptote, but the range is all real numbers. So, all right, let's grab some changes, because that's where it's going to be on your homework, right? Locate 2 vertical asymptotes for the graph and graph at least 2 periods. What do we do to find our asymptotes? Oh wait, hold on. Let's go back. We should write that for this one too. If we want to find 2 asymptotes for cotangent, we're going to set that bx minus c equal to our first 2 consecutive asymptotes, which on cotangent is 0 and pi. Tangent, negative pi halves and pi halves. Cotangent is 0 and pi. It's not that you have to memorize those, just think about where is it undefined, and that's how you know what to set it equal to. And after we do tomorrow, secant and cosecant, we'll kind of summarize that again, because that's probably the hardest thing that we do. So this was tangent. Tangent is undefined when x is equal to 0. So in my head, I always think, okay, x is equal to 0 at pi halves, so I know to set 2x equal to negative pi halves and pi halves to find my 2 asymptotes. And just be careful on your algebra here. What am I going to do to solve this equation? Divide by 2, and what is pi halves divided by 2? Or negative pi halves divided by 2? Pi fourths. You can't just multiply by 2, that's going to make that a 4, right?
Yeah, then you just divide by 4.
Either way, you'll get. That's just silly. Negative pi fourths and pi fourths.
Pi half over 2.
Which means our period has gotten smaller on this one. Now, to get those first 2 asymptotes, I just have to go to negative pi fourths and pi fourths. If you label your graph that way, it's going to look exactly the same, except for my x-axis is going to look differently. What matters is that you get the next one right. They need to be equally spaced. So if I label negative pi fourths and pi fourths, I always see how there's one in the middle. I always like skip the one in the middle. This would be my next asymptote. You tell me what this is that would be my next asymptote. Yeah, this is pi halves. So go pi halves more, and I think you should get 3 pi fourths. And if you're not sure, you could just count 1 pi fourths, 2 pi fourths, 3 pi fourths. So the graph looks the same. That's why, here's what happens on the test. people just don't label their x-axis and they draw what tangent looks like, right? Like if you draw in the shape and you don't label the x-axis, then you argue, well, I had the graph right. Yes, the graph looks like that, but I need to know that you know where the asymptotes are. So that you're going to see when we graph this, okay, well, it's not going to go back to the same because of negative, but my asymptotes are at negative pi fourths, 3 pi fourths, the little crooked asymptotes. The tricky part is when they give you the graph like on a worksheet and you have to fill it in, that's much harder than you making your own. Because when you make your own, that's one period, what's going to happen halfway in between? No, what's halfway in between the asymptotes? 0.
Well, I thought you were saying what's happening between two periods. So you just said what's happening between them.
Now let's be really careful. Normally for tangent, which way does tangent normally go? And if you're not sure, just pick a point. Like you could pick, normally if you pick pi 8, you plug that in there, you're going to get pi 4. Normally this side goes up first, this side goes down, right? Like it looks like this. But what's this negative up here going to do to my graph? So it's going to look like a cotangent, but how do you know it's not cotangent? Because the asymptotes are where tangent are. That's tricky, right? Worst case scenario, just plug the points in and hopefully you can evaluate them. That if you plugged in pi halves, you would get negative tangent of 2 times pi halves, not pi halves, pi 8s, sorry. This would be pi 8s, right? Which gives me pi fourths, which gives me 1 times the negative, which gives me negative 1. I hope that you know the transformations. I hope that you're like, well, normally it goes up to 1, but it's negative, so it's going to flip around. And it's going to go down to 1 first, and then the backside is going to go up. So it's going to look like cotangent with tangent asymptotes. And then I can flip it around. Again, notice that on every single one of these, I am making 3 dots, and I expect you to do the same. Questions about that? Let's do another one. Cotangent. Cotangent is y on the bottom. So cotangent asymptotes are where y equals 0, which means to find my asymptotes, I take this part, and I always set it equal to 0, and I set it equal to pi, and solve that, and that will give you your first 2 asymptotes. Right? So that's the big thing you have to know. Tangent, you set it equal to negative pi halves and pi halves. Cotangent, you set it equal to 0 and pi, which means if there's nothing added or subtracted, this one's still always just going to be at 0, right? But this one, when I divide by 4, I'm going to get pi fourths. Yes? No? Maybe? So label your x-axis accordingly. If I do 0 and pi fourths, right? 0, pi fourths. How far would my next asymptote be? Because that's just a period of pi fourths, right? So another pi fourths away from that would be pi halves. Do you want me to skip one and then do pi halves, or just label the next one pi halves? Skip one?
Skip one, you gotta add a line of bit.
I'm going pi halves. I'm going to squish a lot in here. What would the next one be? 3 pi fourths? Would all of those be asymptotes?
Yes.
They would.
Correct.
Could go negative also. What else is different on this one that we haven't done yet? There's a 3 in front of that, right? So if I take halfway between 0 and pi fourths, what's halfway between 0 and pi fourths? Pi 8. Is that right?
I hope so.
Yeah, that's right. Let's go tangent pi to 0. I'm doubting myself for a moment. Sometimes you just gotta check that you're Monday. What should halfway in between that be every time? 0, and it is. I just checked, right? Like I was doubting myself, so I plugged in pi 8s, and I got pi halves, and the cotangent of pi halves is 0. Normally, for cotangent, when I go halfway this way, I just get, what would half of pi 8? Pi 16ths. And this is how you know if you did it right, because this should equal pi fourths, and does it? Yes. That should say cotangent, not cosine. And what is the cotangent of pi fourths? 1, but what's this 3 going to do to it? Stretch it by a factor of 3, which means instead of going up to 1, I'm going to go up to 3. And instead of going to -1 on this side, I'm going to go to -3. So I've squished in my period in between 0 and pi fourths, and I've stretched that out. That's exciting. And I made like 8,000 periods here, so. If you label your graph like this, you have to fill in the graph. Don't leave it blank, or I'll mark it wrong. Which is why the smart thing is to not make so many darn lines. But it's just repeating itself, right? How fun is that? What else is on your homework? Solving equations. No, it's a good Monday, right? What happens when you don't have homework on Friday? We did this for day 1, that worksheet I gave you. We solved stuff like this. And they're putting them in the sections now. It says solve over the given interval, give an exact answer whenever possible, which means if it's from your unit circle or the special triangles, you should be able to give me exact answers, like pi thirds, or pi sixths, or pi fourths, or 3 pi fourths, right? If it's not from the unit circle, then we have to use a calculator. So the question is, tangent theta equals square root of 3. Could we get that from our unit circle? I think we could. So here we go. This one's no calculator. 0 to pi. Where's 0 to pi? 0 to pi. 0 to pi. Which quadrants from 0 to pi have a positive tangent? Quadrant 1 only, right? Which means although they told me that I could give answers from 0 to pi, tangent is negative over here, which means you got to give me an answer from quadrant 1. Okay? Second step, no calculator. If you're in quadrant 1, you really only have 3 options, right? It could be down here, it could be in the middle, it could be right here. If you're a unit circle person and you know your ordered pairs, you should be able to just fill this in and tell me which of these has a tangent of the square root of 3. Which this is 1/2 square root of 3 over 2. This is square root of 2 over 2, square root of 2 over 2. This is square root 3 over 2, 1/2. Could it be this middle one? It does not have a square root of 3 in it. Which means if you can figure out where you are and it's without a calculator, you should be able to get down to a 50-50 guess, right? Hopefully you don't have to guess. Tangent is which one? Y over x, which means y over x, which one is going to have the square root of 3 on top? This one, yes? Which is 0 to pi, means you better give me radian answers. Pi thirds. Don't give me 60 degrees. It didn't ask for degrees. If you are a triangle person, you can do the same idea in the first quadrant, and you can draw your triangles, and you can say, this is 1, this is 2, this is square root of 3. Which one has a tangent, right? Like that's pi thirds, or you could draw in your pi sixths ones down here. Still get the same idea. These are where there's not a lot of work, to show it's a lot of understanding what the problem's asking and being able to find the answer. What about where cotangent equals 1.2? Is that in my unit circle? No, which means that would be a calculator question. Notice they tell you 0 to 2 pi, and just like that first worksheet that we did, if they tell me to go all the way around the circle, how many answers should I have? 2 answers. Your calculator will give you 1. You have to find the other one. So, step 1 is we have to remember, how do we do this on our calculator? Yeah, this is the same as saying tangent equals 1 over 1.2. And if we're solving for an angle, that's when we use that inverse button. So you do inverse tangent of 1 over 1.2. Should your calculator be in radians or degrees, or does it matter? This tells you what to be in. This is in radians. So in radians, I'm going to do inverse tangent 1 divided by 1.2, and I get an answer of 0.695, let's just say. Radian mode. What two quadrants are cotangent going to be positive in? First and third. Which answer did the calculator give me? First. And if I wasn't sure, I could figure out where that is. That's definitely less than pi halves. That means somewhere up here in quadrant 1, there's an angle of 0.695. And this is where you got to think about reference angles and which quadrants to go to. So your calculator gives you one answer, your brain has to give you the other one. I know cotangent is also positive down here. There's a lot of ways you could do this, but tangent and cotangent are my favorite because they're always positive in quadrants that are diagonal from each other. So in my head, I think, how big is this angle to go from here to here? What angle is this right here? So I'm saying, like, that's a pi, that's 180 degrees. So for me, I'm just going to take 0.695 plus pi, using that idea. Or you can use the idea of reference angles and say you know that this is also 0.695 and pi plus 0.695. You should get an answer of like 3.836 if we're going 3 decimals. This is where you have to use a decimal. You can't give me an exact answer like this. But on number 5, you could give me an exact answer on that question. All right, so this is kind of just reinforcing what we did for day 1. There are some graphing ones on here. There are some matching of graphing ones on here. And you'll see how easy it is to mix up cotangent and tangent. So look for those asymptotes. And we will add on secant and cosecant tomorrow. I think it's pointing to freckles, but you know, I just put a cute little picture there. I don't know. We'll definitely going to have a homework quiz this week, at least one, so don't just slack off on homework. Bye-bye. I'll get all those retests